So we looked a few weeks ago at list views for displaying multiple items of data, and I mentioned at the time they're not necessarily the best or the most modern way of doing things in Android, and that RecyclerViews are a better way of displaying lists of things. So we're going to have a look at using RecyclerViews today. I'll give you an overview of how RecyclerView works. We'll talk about how we can go about setting up the various components that we need for working with the RecyclerView itself, and a card view. The card view is how we define the layout for an individual item within the list. So if you think we've got a series of items, each one has got its own kind of layout. We'll also look at a layout manager. So a RecyclerView can lay things out in different ways. We can have them kind of one below the other, or we can have like a grid layout, or it can do a kind of combination, which is like a staggered grid layout where we might see something on the left, then another one a bit lower down on the right-hand side, so on and so forth. And then we'll go into the details of the classes we need for RecyclerView adapter, and we'll touch on two concepts that have abstract classes, because RecyclerView adapter is an abstract class, and also generics, because it makes use of generics and it helps to have a bit of an understanding. So then we'll look at how we can implement a RecyclerView adapter. So, a RecyclerView brings added efficiencies compared to a list view because it can recycle the views that it shows. So as we scroll through them, a view goes off screen. It can then take that view, reuse it and put it back on screen. So it can provide sort of nice smooth scrolling for vast numbers or very long lists of things. Unfortunately, it's a bit more difficult to implement. So we have to create this RecyclerView adapter thing, and to do that we need some kind of another class called RecyclerView view holder, and we've got to sort out the layout manager, and we've got to sort out a layout for an individual item. So there's quite a bit to it. The other thing we need to do is, because RecyclerView is part of like a backwards compatible library, we have to modify our Gradle build file for the app. There's two versions. The one for the app is the one we want, to include these two libraries, the RecyclerView, and if we're using a card view, which we will, that for the card view. Okay, so I've already got a little project set up in Android Studio. It really only makes use of things we've done already, so I'll take you through what it does at the moment. And then we're going to add a RecyclerView to it. So at the moment, if we run our application, and get the zoom right, you'll see that we've kind of got an empty screen, and we have a menu item that says add. When we go to that, it presents us with an additional activity. We can add a score. So it's a very simple scorekeeping app. We can provide a score for us and our opponent, hit add score, and will be passed back to the main activity. And that score is actually passed back, but currently we don't do anything with it. So we'll have a brief exploration of the project as it stands as well. So in our resources folder in layout, we've got this add score layout, and we've got a main activity, which is, it's got a toolbar in it. Okay, so if we have a look, you'll see it's got a toolbar in it, but it hasn't really got anything else in it at this stage. Make a bit more space. It's not quite the same as I've started with an empty application, but I've manually gone in and added a toolbar. When you come to do the tutorial for this, you'll go through that same process as well. I don't see any reason why we couldn't have done it starting with the basic activity and just removed the action button, but I've done it this way. What else is there to talk about? So in terms of the view controllers, in terms of our Java code, or is the activity, sorry, main activity, it sets up this action bar, so the toolbar, and it inflates the menus. Okay, but we've done menus before, and then we've got an action if we select an item in a menu which presents that other activity, the add score activity. And if we get a result back from that activity, we're passed a score object to it. So this is nothing different to what we did in the list views tutorial. Okay. The only thing you might want to be aware of is there's a score class. The score class is relatively simple. It has an int value for your score, an int value for the opponent's score, and a date, although we don't currently use the the date, but it might be there, might be useful later on. So that's kind of the project itself. So as we can see for the slides, the first thing we want to do if we want to use the recycler view is to add a reference to our build.gradle file. It is build.gradle, isn't it? For the application, okay. If we were to try and just drag on the recycler views, if we were to open up our main activity and go into design view, we'd see it's in the palette and it's got this little download thing next to it. So we can actually have our project add that reference for us. So I'll click cancel for a second, just show you the build.gradle file. Doesn't include that the line of code, the recycler view currently, but if I go to back to the activity and try and download recycler view and say okay, it synced the project, and if we go to our build.gradle file, it's added that in at the bottom. We also need to do it for the card view, and the card view doesn't exist in the palette, so we'll have to type that one in by hand. So implementation com.android.support card view -v7 : and then we're going to match the version with the version of the recycler view, which also happens to match the version that we've got here for our app compat library. Okay, if this is a different version, then we'd use the matching version down here. So we're targeting the same SDK version. And then hit sync now, and we should now be in a position where we can actually use the recycler view and we can use the card view. Okay. So we've already dragged that. We haven't dragged the recycler view in, but we have added it. It's now available to us from the palette. So if we want a recycler view, we can drag that into here. We should be able to. Didn't seem to like that. Let's try again. It won't let me drag it. This is being excellent. Why is it not doing that? I can't even select anything. I'll close it and reopen it. Okay, still trying to do a build. Appears we may have a problem with Android Studio, so I will just try and stop it. Let's just go back here. Not got any problems there. Build, make project. We've got a warning, but that's not a problem. That's built okay. Let's try again. Doesn't want to play today. Okay, I will quit Android Studio and relaunch it. Okay, seems to be back alive. So we'll drag our recycler view in. We do need to position it, so we can go into the text view for our recycler view. What are we getting a warning here? Oh yeah, it's just not constrained currently. So I think we probably want to specify that it is going to basically be filled up by the items that are going to go in it. So we can set the width and the height to 0 at this stage. And we constrain the end to the end of the parent, and the start to the, really want to constrain the start to the start of the parent, so that's our left and right, but we also need to constrain the top and the bottom. So we can say constraint underscore top, and we'll constrain the top. We want constrain the top to the bottom of something. Where's that gone? Constraint, we want top to bottom of. Why is that not there? Constraint. Oh, there we go. Oh, it's disappeared again. Top to bottom of. And we'll constrain it to the toolbar that we've got. And then we'll constrain the bottom to the bottom of parent. Okay, so all being well, if we go back and review that, it should sit nicely, and it even gives us a little preview. You can just about see, try to make it a bit larger, you can see it's previewing some items in there, although we haven't actually specified the layout for how the recycler view is going to look quite at this stage. Okay, so we've added a recycler view, we've made it fill the required area. Okay, so each individual item in our recycler view needs a layout, and we can use a card view for that. So I'm going to create a card view, and I'm going to fill it up with some elements. It's going to keep score, this app, so I'm going to have some text views to display the score. So we'll need to add a new item to our resources. Okay, so we can go into layout, we can add a new layout resource file, and we are going to use a card view. So if we hadn't added the reference to the card view to our build.gradle file, then I don't think we would see it when we start to type the card view, but because we have, it's available to us, android.support.v7.widget.cardView, and we could name it something like card view underscore score, I think, because it's going to show a score. So we'll hit OK, and we've got a layout for that. Now, we need some kind of system for laying out the elements that we put in it. It doesn't currently have like a constraint layout or one of the other layout types. We could use a constraint layout, but because I'm lazy and I just want 3 things to sit next to each other, I'm just going to use a linear layout. So I'm going to drag that in there. And then I'm going to add 3 text views to my layout. It's going to show my score on the left, a colon in the middle, and the opponent's score on the right. So I'll drag those in, 1, 2, 3. You can see they're all sitting next to each other. I'm going to change the text, so I'm going to specify the middle one's got a colon. And for now, the right one is going to be a 0, and the left one is going to be a 0. These will be changed programmatically. They're really tiny at the moment, so I'm going to change the text size to 24 SP, and I'm also going to give them IDs. So the left one is going to be my score, so I'll do TV U for me, as in my score, and this one can be TV opponent. I can't spell opponent. Is it A-N-T or E-N-T? E-N-T. Thanks. And then this colon can go in the middle. We kind of need to do a bit of, as I say, we need to change the font size. We need to kind of lay these out a little bit better. So if I go to View All Attributes, we should see text size down the bottom. So I'm going to make my text size 24 SP for each of them. Okay, I also only want the colon to take up a little bit of space in the middle, so we can change the weight of the items in our view so that they get that amount of space depending on how much weight they've got. So at the moment they're all weighted at 1, but if I weight the outer 2 to 5 each, they'll both take up 5/11ths of the display, and the colon will take up 1. I also want the each thing to be centered inside its label, so we can use a gravity option for that, wherever gravity is gone here, and we click that and expand it. We can decide that we want to gravity center. Oops, I've selected the wrong thing there. I selected the layout there, so that's why it jumped to the middle. I'm going to change that to the individual element and go back and set the gravity for that to be centered. So that's that. There's our colon, and there's our right one. So that's our card view. The other thing we just need to consider is where things sit in terms of how much space they take up. Okay, and we can leave these two as match parent, and I think we should be good. And the linear layout is match parent. Hang on, let's just check that. I don't think that's right. I'm just checking here because I can't remember quite exactly how I did it. Yes, so the layout height for the card view is wrap content, but for the linear layout it will be match parent. Okay, so that should mean that our card view only takes up as much space as it needs, but we can test that by having a look in the preview. So that's our card view. We can see kind of what it looks like here, and we can see that it's now taken up just to match the height, so it's not as tall as it was before. It wasn't filling the whole space. I can preview it. If I go back to my activity, you'll see this doesn't seem to show the card view, okay? I can actually say that I want to display, this is only for the preview, it doesn't have any effect on our actual application, it's only so it looks good here, so we can see what it's going to look like, by choosing to use my card view here. So if I do that, I'll get an idea of what it looks like, okay? But this does not affect, if I was to run my application, it has there's no sort of connection made in terms of how the RecyclerView knows what its card view is. It's only for the purposes of this layout thing so that we can see what it looks like. Okay, so we're getting there slowly. We've created a card view. We've set it to wrap content so that we can see more than one item in the RecyclerView at the time. And we've added a layout. We used a linear layout because I was lazy, and we've added some UI elements. So that's an individual item in a list view. We need to tell our RecyclerView how it is going to lay out each card view in relation to the other card views. And we get different layout managers we can use. We can use a linear layout manager, a grid layout manager, or a staggered grid layout manager. We can subclass and create our own layout manager by just subclassing RecyclerView.layout manager, but chances are we won't need to do that. And the code for that is relatively straightforward. We tell our RecyclerView that its layout manager is whichever type of layout manager we want and pass in the context. So we can do that. We can go to, well, one, we need to know what the ID of our RecyclerView is. Currently doesn't have one, so I'm going to call it RecyclerView. RecyclerView, yep. And then I'm going to go to the the Kotlin, sorry, for my main activity. And on create, I'm going to say that my RecyclerView layout manager is going to be a new linear layout manager. And we pass the context. Everyone know how to get context? Where do we get context? What context? Where can we get context from? What extends context? We did this before. Anybody? No? Okay. Well, an activity extends context. We're in an activity, so we can just use this. Okay. So now our RecyclerView has a layout manager. So that's kind of easy. Where it gets more difficult is when we come to actually create. We have to create a RecyclerView adapter, an instance of RecyclerView adapter. Now, RecyclerView adapter is an abstract class, which we'll talk about in a minute. And its purpose is to allow us to get data from some data set. That just could be like a standard list or an array or something like that, and bind it to the views in the RecyclerView. So we take data from a collection and make it appear on screen. That's the RecyclerView adapter's job. Probably helps just to know a little bit about abstract classes. So an abstract class is one that contains one or more abstract methods. And you might think, well, that tells me almost nothing. Well, an abstract method is one that's been declared by not implemented, but not implemented. And then you might think, well, hang on a minute, that sounds just like an interface. Okay. Well, the difference between an abstract, or one of the differences between an abstract class and interface is that some of the methods may be implemented. So we might have some methods that are not abstract, okay? And we can't just instantiate an abstract class. It's not like a regular class. We have to subclass it and implement those abstract classes before we can use them. So then you might think, well, hang on a minute, all of those things, you know, apart from the fact that we might have some methods that are abstract, actually they could apply to interfaces. And you might think, well, I've read a bit about Kotlin and actually know that we can have implementations of methods in Kotlin. So how on earth does that differ at all? There's a few subtle differences. In terms of similarities, they can both declare unimplemented methods and they can both implement them, okay? But properties with an interface can't have a backing field. So if you remember when we started learning Kotlin way back at the start of the year, we did talk about computed properties, getters and setters, and that kind of field variable if we wanted a backing value. We don't get that in an interface. The other thing is a class can only implement as many interfaces as it likes, but we can only inherit from one class. So if we have an abstract class, if we inherit from the abstract class, we can't inherit from any other classes. We're limited to inheriting from that abstract class. Okay, so there is a slight difference between, or a reasonably major difference between interfaces and abstract classes in Kotlin. So that gets us part of the way. We know what an abstract class is, but actually we also, when we come to create our recycler view adapter, it's actually got a type, okay? Because it has to have a special type of something called a view holder, so that it knows what is holding its view, basically. This gets a bit more confusing, and to kind of understand it, we kind of need to run down another rabbit hole, which is to talk about generics. Okay, so there's some Kotlin code up here. We've got a string list variable, which is called string list. It's a list of strings, and we create it by calling list of, passing in string as a type, and creating a list of some strings. And then we're creating another variable where we're using the last, we're calling last on our list. Okay. So we've got a type of list, we're using the list's last property. We've then got another one where we're creating a list, this time we're using integers, and we're calling last on that list. And here we get back an integer, there we get back a string. Now, anyone got any idea what the return type of the last method that belongs to list is?
What the last?
So
looks like the last string of the.
So if we were to write it, we would say, if we write a method that returns something, we do something like, fun, my method name, brackets, and then you have a colon, and it returns something. So we might return a string, or a method might return an integer. But here, last is returning a string, but there, last is returning an integer. So what is the return type? Or are there just lots of different last methods for all different data types? Or is something else happening? Not sure? It's a tricky one, isn't it? It kind of doesn't make sense because we're used to returning things of a particular type. And here it seems that the type can return whatever we want. But surely whoever wrote the code for the list object didn't sit there and write a fun list colon int, fun list colon string, and did all sorts of different methods that return different things. So no, it doesn't. And let's have a look. We'll actually look at the code to see how that looks. So if I come back here, let's just say, just for the time being, we create a list. So we can say var list equals list of string, apple, banana, so on and so forth. Okay. Let's have a look. So we can jump to the definition of, we want to call the final method. So we want to do val fruit equals list.last. Okay, so we can have a look at the implementation of this last method. So let's do that. Let's right click and go to declaration. So this is the Kotlin's collection file, and we can see in it, here is the function for list, and it has a method called last, and it returns a t. Okay, so this refers to the type that matches the list. So when we create a list of a particular type. In this case, in the case we've done it as a string, and that type is used as the type for what that method returns. So there we go. We've said there's a type, it matches a list, and we return something of that type. Okay, so if we were to create a different list of a different type, it would return a different type of thing. So I'll just take that out for now. in terms of how we refer to these things, so list is what's called a generic type, okay? It has a special type of parameter that's declared by the angular brackets, and we use those angular brackets to specify the type of thing it is, okay? When we instantiate a generic type, we instantiate with a type parameter, in this case, might be string, and when we do that, we're saying it's a parameterized type. Okay, so when we come to look at our recycler view adapter, you'll see it has it's a generic type, but the type parameter we specify must extend RecyclerAdapter.viewHolder. So it's kind of generic, but it's restricted to being something that extends the RecyclerAdapter viewholder type. Okay, so that's known as what's called a bounded type parameter. So one way we can do that is when we go to create our RecyclerView adapter, we can create like an inner class. So we've done a bit with inner classes of type RecyclerView viewholder. Okay, that we subclass. We create our own implementation of that because this is abstract as well, and then we specify that as a type. Okay, so it might help just to see it done in practice. It's not quite as bad as it looks. So there's an example, but we'll create our own one and we'll work through it. We'll probably come back and refer to this slide as we do so. So I'm going to add a new class to my project. We will call it, I've made it really long in the last lecture and it was kind of over the top. I'm going to call it score adapter. So this is going to be, and it's going to be a class. Okay, now it will eventually extend from RecyclerView.adapter. So it will extend from RecyclerView.adapter. And then we have to specify a type for that. But to avoid seeing warnings all over the place, for now, we'll put that back in a minute. So because when we extend that RecyclerView.adapter requires a view holder, we need to create an inner class that implements the RecyclerView, let me get this right, the RecyclerView.viewHolder. Okay, so what we might call this is a score view holder, okay, and that implements the RecyclerView.viewHolder class, okay. Now, RecyclerView viewholder has a constructor, so we have to call the constructor, and we have to do it here because Kotlin says we do, and it requires a parameter of item view, okay. Well, that's really helpful because I don't have one, but what I can do is I can make sure my score view holder, i.e. the subclass, also takes an item view. And if we were to go and see what an item view is, pretty sure it's a view. There we go, it's a view. So we can say item view, and we can pass that item view in here. Okay, and we just need to add that import statement. Okay, so we have created our own instance of the RecyclerView viewholder class. Okay, which is, if we go to it, oh, don't freeze up on me. There we go. So there's the constructor, but where is it? Here we go. Here's our abstract class. So we've actually created an implementation of that. Okay. At this stage, we don't actually have to do anything with it. It has got a number of methods we might implement that aren't implemented, but we're not forced to implement any of them at this stage. What we do need to do, though, is to say that our score adapter extends the RecyclerView.adapter class, and that is typed, and the type can be a view. It needs to be a RecyclerView.viewHolder. Well, we've created that now, and we've called it score view holder. So we can say that this is a score view holder. Okay, let's see what it's thinking about now. It's saying that that's got a constructor, so we must construct it here. What does that constructor require? No parameters. Well, that's nice and easy. Okay, and now it's complaining that there are abstract base class members that need implementing inside the RecyclerView adapter, so we need to implement inside our score adapter. We can get kind of a shortcut by using the little light bulb, or doing Option and Enter or Alt and Enter. Choose implement members, and it will pop up with all the methods that we need to implement to build our RecyclerView adapter. So I've selected them all and I'm going to click on OK. So it puts them all in, but it adds these comments saying they're not implemented. I'm going to get rid of the comments for now. It also isn't terribly helpful because it doesn't name the parameters properly. It just calls them like P0 and P1, and that doesn't really tell me much about what they are. I can infer that this one is some kind of view group, but I don't actually know what this one is without looking at documentation or going to my slides where I happen to have named it, and it's a type of view. We don't actually use it here, but it's a lot easier if we come back to things if our parameters are named. Here we've got a method called getItemCount, so it's got to return an integer. We don't currently have any items, so I'm going to just return 0 for now. Why is that complaining? So this method has got to return a score view holder, so we'll come to that in a minute. And we've got a method here called onBind view holder. Well, here we get a view holder. I don't want that view holder. And we also get this integer which refers to the position in the recycler view where something appears. And that's quite useful because we might need that to figure out where in our collection of things we're going to display that, that view holder comes from. I've got a problem though. I've got no collection to use. I need a collection of something, a collection of scores, in order to be able to display them. Okay. So what I'm going to do is I'm going to add a property to my score adapter. I'm going to call it scores, and it's going to be a mutable list of score. Okay. So now, instead of returning 0 for the item count, we can return whatever is the count of our scores, or the size of our scores. Okay, and we can start thinking about how we're going to implement these methods. So what has to go into onBind view controller? Well, we have to inflate a view, and this is where we actually hook up our card view to our recycler view. Okay, so we use a layout inflator. We use the context of the view group from our recycler adapter, and then we inflate a particular layout, in this case, whatever our card layout is called, and we pass into that the view group. And I didn't actually check what this does, but for attached to root, we specify false. Anyone wants to look up on what that does, feel free to look it up and tell me. But we'll do that. So we'll create a view, and then we return a view holder passing in that view value. So let's do that. So we can do something like val view equals layout inflator dot from. The context is the view group dot context. And then what do we do next? Inflate, yes. Inflate, okay. We inflate our card view layout, which is card view score. We pass in the view group. And as I said before, it will let me do it without attached to root, but I haven't tested it. So I'm just going to pass in false here. Probably should find out what that does. Maybe you can do that for your reading. And then we need to return a score view holder, and it needs to have that view. So we can do return score view holder and the view. Return score view holder. So that's this. So we're creating a new score view holder, and we're passing in the view that we've just created by inflating out the card view. Okay. So this will happen a lot of times because obviously we've got a lot of different card views. Okay, so that's our onCreate view holder. We also need to bind the data in our view holder to the data that's coming from the our list of scores. So here we can say something like view holder dot item view dot, and this is our card view. So the text views we created earlier in our card view are available to us. Here's my U text view. So I can get its text property, and I can say, well, I want that to be something that comes from one of my scores. Okay, just so we're not putting lots and lots of code on one line, I'm going to say something like val score equals scores, and we use the position that we are in our recycler view to obtain the score at that position. So then I can say score dot u. That is an integer, so I need to convert it to a string. Okay, and then we can do the same for our opponent score, which is a text view opponent, and it's its text property that we want to set to our score properties, score object's opponent's properties integer value converted to a string. Okay, so all being well, that's most of the job done. Okay, we've implemented this RecyclerView view holder class, which is an abstract class that we've created a concrete instance of, but we don't actually have to implement any methods, although we, as I say, we will later on in the next week's lecture. We have worked out how many items there are. We've instantiated each card view by passing in it the type of layout and inflating it, and we've bound the various bits of the card view to the values from the scores. So the only thing that currently doesn't happen is when we get back from our activity that adds a score, we currently don't do anything with the score. So really what I need to do is to take that score and I need to put it into the recycler view. But I am missing something, okay? And that is my recycler view doesn't know what its adapter is. So currently there is no adapter for the recycler view. So what I could do is I could say RecyclerView.adapter equals, and then we could create a new instance of our score adapter. And away we go, okay? So what I really want to do is tell my score adapter here that if I go to my score adapter, I want to give it scores a new score, and then tell the score adapter that we've added something new. So it'd be nice if I could just write something like RecyclerView.adapter.scores, but I can't see the scores. Does anyone know why I can't see the scores? So here, RecyclerView adapter is set to a score adapter. Score adapter has it's not private scores object, but I can't access it. Any ideas why? Anyone like to take a guess? What does a RecyclerView adapter have to be? Can we, there we go, what does that tell us? See, it's a RecyclerView adapter, okay, but I've got a specific type of RecyclerView adapter, which happens to be a score adapter, okay? So I could cast my RecyclerView adapter as a score adapter, okay, and then once I've cast it, I can then access its scores, but that's a little bit messy. So what I think would be nicer to do is to actually keep a reference to the RecyclerView adapter that is typed as a score adapter inside main activity. Okay, so we could declare a, we could say something like val scores adapter equals, well, it's going to be a score adapter. Okay, but in fact, I'll make it variable. We actually need to instantiate it here. We can't instantiate it here. Okay, so what I'd like to do is then say, okay, well, scores adapter equals score adapter. Maybe I should have called it score. Let's make it score. And then here we can say this is a score adapter. But we've got a problem that properties must be initialized or be abstract, but I don't want to make it abstract. We've had this problem before. How do we fix it? When we can't instantiate it, we can't instantiate it in the constructor, but we do want to initialize it. We are initializing it. We know it's initialized because it's going to be initialized in onCreate. onCreate is not the constructor. There's a special word we can use to say that we are going to initialize it later. Late in it, yes. So we can say late in it, and we're promising that we'll instantiate it, and we do. Okay. So now, rather than having to go to my RecyclerView adapter like that, because I've got a reference to the same object in score adapter that's typed as a score adapter, I can say score adapter dot scores dot add. We'll add it at the beginning, and we're going to add this score that's come back in the intent from the other activity. That's not quite enough because we need to tell the RecyclerView that we have added a new item. So we can then say something like scoreadapter.notify item inserted and the position at which we've inserted it. We don't really want to do dataset changed because it will refresh the whole dataset, which could be slow. Inserting should just put it in for us like automatically. So, assuming I haven't screwed up royally, which is always likely, we'll run it and see what happens. So let's have a look. This is executing tasks. Haven't got any output. But nothing is happening. And also my dock is sitting above Android Studio, which is not a good sign because you'd think it would go away. Gradle build finished. Okay, so it has launched, just slow. So we should be able to click here and click add. Should this time be able to add a score. And then we can see it's inserted. If we add another one, you can see a little animation of it being added at the top there. Okay, we're going to do more on RecyclerViews next week, but for now, that's all I'm going to cover. Are there questions on anything I've covered so far?